let's record. So first off, when we talk about differentiability, we know that a function is only differentiable at a point, or is not differentiable at a point, if 4 criteria are met. Oh, somebody else is counting. So not differentiable if we have a corner, if we have a cusp, if we have a vertical tangent line, or if we have a discontinuity. Okay, that's just somebody asking for Chasanya, I'll get to yours in a second. So those are the 4 reasons why a function might not be differentiable at a point: corner, cusp, vertical tangent, and discontinuity. The reason for all of the first 3 is that the slopes from the left and right are different. And remember that a derivative is just a limit. So if the limit from the left and the limit from the right are different, then the derivative can exist, or that limit can exist. And then a discontinuity, you can't have a derivative at a point where the function doesn't exist. And then you're asking specifically about endpoints, right?
Yep.
Yeah, so when we talk about derivatives at endpoints, you can take a derivative from the right of a left endpoint, and you can take a derivative from the left of a right endpoint, but technically there are no two-sided derivatives or full official derivatives at an endpoint. That
got it. But like in our cases, it usually doesn't matter because like most of the theorems, they exclude the endpoints, right?
Correct. Yep.
Okay.
Yep. And normally anything that has like closed interval on the endpoints, if they're asking about an absolute max or an absolute min, where you would need to find critical values, it won't matter if those are undefined there, because you gotta check the endpoints anyway for a closed interval. So that makes sense?
Yes, thanks.
Sure. All right. Let's see here. So next question that somebody asked was inverse rule for derivatives. So the inverse rule for derivatives says that if f and g are inverses, then f must contain a point AB, which means that g contains a point BA. And the inverse rule for derivatives just specifically states, oh no, my laptop. Weird. Okay, can you guys still see the screen?
Yeah.
Okay, sorry, I don't know, it just did something weird. All right, so if f and g are inverses, f contains the point AB and g contains the point BA, and that the derivative of f at A is equal to 1 over the derivative of g at B. That's the inverse rule. So oftentimes this shows up in the multiple choice in a problem where they'll give you a bunch of information, like they'll say that, they'll give you like a chart of values or something. X, here's F, F prime, G, and G prime. And let's say they'll say this is like 1, 2, and 3. And I don't know, we'll go with let's go with 2 and 4 and 3, -1. Go with 5, -2. Let's see. Now that let me make sure I make something that actually works here. Yeah, that works. Okay. All right, let's go with this. So suppose that they asked you what is f prime of, let's just say f prime of 1. So what we would do, oh, well, let's pretend they didn't give us this. Yeah, pretend they didn't give us all that. Okay, so they asked us for f prime of 1, and we would then say that must be equal to, well, f contains a point 1, comma 2. So G must contain a point, which it does, 2, comma 1. And f prime of 1 ought to be 1 over G prime of 2. And so you just go and you look at what is G prime of 2. It's negative 4. So you get negative 1 over 4. Does that make sense? Everybody good with that?
It makes sense to me.
To Sonia, you good with that? I know you were asking that.
Yeah, that makes sense. Thanks.
Mm-hmm.
For this one, what if it asks you to solve for, wait, I'm trying to figure out how to word the question because I'm looking at a specific one that has it. But if it gives you f prime and you're looking for g prime of b, how do you do that?
Same thing. You just cross multiply, make it G prime of B equals 1 over F prime of A.
Okay.
So, if it said what is, in this particular case, it would have to say like, what is, let's say they didn't give us, well, yeah, if we wanted to find, let's say G prime of 3, we look at the point G. G has a point 3. Oh, that's not what I wanted. Darn. Well, I don't have anything that matches up correctly on here to show for G, but you literally just you just cross multiply these to switch those around, and you find the point that corresponds with G as, if they asked you G prime of 2, it would just be 1 over F prime of 1, which they'd give you a value for. Does that make sense or no?
Yes, thank you.
Cool. Yep. Any other questions on this one? All right. Okay, so Alex, the 2013 multiple choice 87. Let me pull that up. Give me 1 second to pull that up on my phone so I can see what the problem is. 2013, right?
Yeah.
One second, I'm scrolling through it here. There we go, 87. Okay, so they gave you f prime as 3 minus 2x minus x squared times sine 2x minus 3. And so in order to figure out how many relative extrema f has on the open interval from -4 to 2, you just need to graph this derivative and see how many times it crosses through the x-axis from -4 to 2. So we'll just there we go. So what was our function? It was 3 minus, that is 3 minus
2x minus x squared.
minus x squared.
Yeah. Times sine 2x minus 3.
Sine of 2x minus 3. I don't know why that box keeps popping up. So we look at it from -4 to 2. Looks like it crosses through the x-axis once, twice, 3 times, 4 times, 5 times, 6 times. So 6 local extrema.
Oh, okay. On my little small graphing calculator, that the 2 right there between -4 and -2 looks like it just hits the x-axis and bounces off. But okay, those are 2. I see.
Yeah, so my recommendation is if they give you a specific interval, like here they said from -4 to 2, change your window to be just from -4 to 2.
Okay.
You guys all hopefully know how to change your window on your graphing calculator. Just hit the window button and then change the x values.
Yeah.
Yep. Cool. So that's what I would do. That make sense?
Yeah. Okay. Thanks.
Yep. All right, let's see here. So the next question is, how would differentiability work for Rolle's theorem? Doesn't it rely on the idea that a function has a tangent line of 0, but the slopes from either side leading up to that turning point different? I guess I'm not sure exactly what you're asking me. What is that, Cassie?
I can try to explain better.
Okay, I mean, well, so if you're talking about the value that satisfies Rolle's theorem, that from both sides the slopes are different.
Mm-hmm.
Yeah, so your value that satisfies Rolle's theorem, right, is that value where the slope of the tangent line is 0. And so for that, I mean, as you come in from the left, the slope is approaching 0, and as you come in from the right, the slope is still approaching 0. So it's approaching the same value, just from different, from the positive and from the negative side.
Oh, I see. So
Yeah,
this
so
would.
still- Sorry, say it again?
So this wouldn't work for functions like an absolute value function, for example. It would only work for like curves.
Correct. Yep. because-
Okay.
yeah, it has to be differentiable, so it has to not have a corner cusp, vertical tangent, or discontinuity.
Thank you.
You're welcome. All right, next question. Restricted exponential growth and decay like Newton's law of cooling. How to write it as a differential equation and then the solved form. So we only really briefly talked about Newton's law of cooling, I think, just for a minute. They don't usually put Newton's law of cooling on there. It's just an exponential growth or decay. Just a slightly more complicated one. So the equation for it, let's see if I can remember it off the top of my head, is the temperature minus the surrounding temperature equals the initial temperature minus the surrounding temperature, e to the kt, I believe. Anyway, that just comes from a differential equation. The only difference is that we've got these temperatures surrounding temperature versus the temperature of the actual thing. And the only difference is, normally we started off as like dy dt equals ky is the differential equation version. It's a separable differential equation. And so, yeah, you just separate the variables. And the idea is that y is now temperature minus the surrounding temperature rather than just y. But everything else works exactly the same. So you basically just separate the variables, dy over y equals k dt. And then integrate both sides. Calculate absolute value y equals kt plus constant. And we know that when t equals 0, or effectively up here, when our temperature of the surrounding area is equal to the actual temperature, then sorry, I'm saying that wrong. So like when t is 0, we know that the y value here is y naught. Well, same thing here. When t equals 0, we know that the temperature and the temperature of the surrounding stuff is far away as possible to be, but it's still the initial temperature here minus the surrounding temperature. So the surrounding temperature, these T naught and these T sub s will cancel out when you plug in your initial condition. And so this ends up becoming a constant of natural log of y naught. And when you end up solving it, it becomes y equals y naught e to the kt. And that's just your exponential growth equation. And same thing comes from the from the temperature minus the surrounding temperature and the initial minus the surrounding. Works out the same exact way. But I
Okay,
would,
that makes sense. Would
Yeah, I
we
wouldn't
see this on
expect to
multiple
see-
choice if it was there?
say that again?
If it was there, would it be on multiple choice?
No, it'd probably be, well, yeah. I think I've seen that once, but they gave you the formula for it. So, like,
Oh, okay.
yeah, I wouldn't be too concerned about it. Usually the only way they might do one of these where it's exponential growth or decay in the multiple choice, where they don't give you, the thing is they might just give you this, dy dt equals 7y, and ask you to solve given some initial, let's say that t equals 0, y equals 10. They'll give you that. And so they'll expect you to know that you don't actually have to integrate this, that this just becomes y equals y naught e to the kt. And so with k is 7, this will become, y equals the initial amount, which is 10, e to the 7t, and you can just use that formula to find whatever, the time at which it's at a certain amount or the amount at a certain time.
Okay,
make
thank you. Yeah.
All right, let's see here. Yeah, DM, y sub 0, y naught is the initial, correct. All right, Evan. (2012), number 26, right?
Yep.
Give me a second to open that one up and find it. My phone's going slow here. Ah, there it is. Okay. It's so small on my phone. It's hard to read. I was just helping someone with one similar to this. So g is a function where g prime is the integral from 0 to x of e to the negative t squared dt. That's the one you're talking about, right?
Yeah.
Okay. Good. So it asks us a bunch of stuff about the interval 0 to 2. Most of it is about being increasing or decreasing, or concave up or concave down, or having a point of inflection. So first off, we should know something about the function e to the negative t squared. Right, e to the negative t squared. What can you tell me about that function? That no matter what I plug in for t, what is the value of this?
It's always going to be positive.
Positive. So that's going to help us, because that's telling us if we want to look for the area underneath the curve, right? That's what g prime is telling us. G prime is this integral from 0 to x, telling us that g prime must also be positive. Because if this function e to the negative t squared is always above the x-axis, then the integral of it from 0 to any x value is always going to be positive. Does that make sense? Or no?
Yeah.
Are you sure?
I think so. Like it kind of does, but at the same time, like, can't you have a negative slope when it's still like above the x-axis? Like, I don't know.
Yes,
I don't know if that makes sense.
remember, the function that represents g prime is an integral from 0 to x of this function. So no matter what value, this is above the x-axis, right? Or technically above the t-axis, but that's fine. So if the derivative represents the area under the curve of e to the negative t squared, and e to the negative t squared is always above the x-axis, that area will always be positive. Good or no?
Okay, yeah.
You sure?
Yeah.
Okay. So we know that the function, so if the derivative is positive, we know that it's increasing. So that'll allow us to eliminate choices C, D, and E. Then we take the derivative of this, g double prime. G double prime is, using the first part of the fundamental theorem of calculus, just the derivative of an integral from a constant to x of a function. It's just that function. And we already said that this function is always positive. So that function is always positive, then that tells us that it must be concave up. So we've got increasing and concave up, which would appear to be choice A. Is that good or no?
Yeah, I knew that that was the answer, but and I knew kind of why. I just needed it to be explained again.
All right, as long as it makes sense now.
Wait, Mr. Bachelor,
Yeah.
I have a question. If you plugged in 2 to the derivative there, wouldn't that make the derivative negative, since like e to the negative 2 squared minus e to the 0 is a negative?
No, you didn't integrate that function. You just plugged in 2 to that function and 0.
But like, wait, wouldn't evaluating the integral be like e to the negative 4 minus e to the 0? Like,
No, you'd have to
that's-
integrate that function. You're not integrating the function,
oh, okay.
right? If I just put like 2x in here and said 0 to x, well, you wouldn't just plug in 2 times the 2 and then minus the 2 times the 0. You'd integrate 2x to get x squared, right? And then plug them in.
Oh wait, yeah, okay, never mind. Thank you.
Yeah, and this is the reason they've used this function there is because that's a function that doesn't have an elementary antiderivative. It means that there's no explicitly defined function that actually has that as its derivative. So the point is you're not able to find the derivative, but you do know that it's above the x-axis. That's the whole reason they put this one on there. Is that good for everybody?
Yes, that was my bad.
It's all good. All right. Let's see here. Let me find the next question. I'm a little ways ahead now here. 86 from 2012. So let me quickly scroll down to that one. That's the one called charts, yeah? All right. So we know that f prime is positive, and we know that the integral from 4 to 7 of f of t dt is 0. And we want to know which chart makes sense. So if the derivative is always positive, that tells us that f must always be increasing. So if we're looking at the charts there, hopefully you're all looking at the charts in your Google Drive as you're doing this. It tells us that f must always be increasing. So if you look at chart A, f is increasing, so that's good. Chart B, it's also increasing, so that's good. Chart C is not, chart D is not. So you can eliminate those, but E is. So everybody good that A, B, and E are currently our only options?
Yeah.
Okay, and then the second part of this is that we know the integral from 4 to 7 must be 0, which means that we've got to have some section that's above the x-axis and some section that's below the x-axis, right? So if we look at choice B, or no, sorry, A, choice A is all below the x-axis. So the integral couldn't come out to be 0 if everything was below the x-axis. And then the same thing with E, the integral couldn't come out to be 0 if everything was above the x-axis. But choice B, it's sometimes below and sometimes above. So that's the only one where it could come out to be 0. Does that make sense to everybody? Yes, no, maybe.
It makes sense to me.
Oh, good. Anybody else?
Yeah, that's good.
All right. Let's see here. Next one is 85 and 86 from 2014. Sorry about that. All right. Pulling up 85 and 86 from 2014. All right. All right, 85 says a particle moves along the x-axis. They give a velocity as t squared minus 1 over t squared plus 1. We want the total distance traveled between t equals 0 and t equals 2. So remember that total distance traveled, not displacement, but total distance traveled is the integral of speed. Speed is the integral of, or the absolute value of velocity. So this should just be the integral from 0 to 2 of the absolute value of t squared minus 1 over t squared plus 1 dt. And then you plug that in and you get some number. I don't offhand know what it is, but is that good or no? This is really important point here. Need that for those FRQs too. Remember we did some of those with the FRQs. And displacement is the integral of velocity. Distance traveled is the integral of speed. Everybody good there or no?
Yes.
All right, and then the next one, which was just the next problem on that 2014 test, 86. Says L is tangent to y equals e to the x. Handwriting is especially bad. And we want the y-intercept of L to be half. And we want a positive value of k. So k greater than 0. Okay. And we're using what I put the point on here. The point is k e to the k. Everybody good with that? Okay. So, somebody said something in the chat. 1 second. Yeah, I'll get to that in a minute, Evan. Okay, so if L is tangent to y equals e to the x, then the derivative of that, the slope of that, ought to be e to the x. And if we're doing it at the point k e to the k, that should be e to the k. So we have a slope of e to the k through a point k comma e to the k. So using point slope form, that should look like y minus e to the k equals e to the k times x minus k. And then we're looking for the y-intercept to be a half. So if we want a y-intercept, that means that x is equal to 0, and y should be a half for a y-intercept. So 1/2 minus e to the k is e to the k times 0 minus k, or negative k. So you just graph this function, you graph this function, and you use the intersect function on your calculator to find out what k is. Does that make sense to everybody or no?
Yeah.
I don't remember who asked that one now, but Sydney, is that good or no?
I think so. Why did we do derivative y again?
We took the derivative of it because in order to write the equation of this tangent line, we need the slope. The slope comes from the derivative.
Oh, okay, yeah.
We take the derivative to get the slope. They give us the point. We write it in point slope. And then this is L, right? L is y minus e to the k equals e to k times x minus k. We want it to have a y-intercept of a half, so we plug in 0 for x and a half for y.
Okay, yeah, that makes sense. Thank you.
Okay. Cool. All right, 22 from 2015. Okay, give me a second here. Pull this one up. Okay, you guys don't like these ones with K's in them. So f is kx over x squared plus 1. And we want to know for what values of k is f decreasing, only decreasing from -1 to 1. So if we want f to be decreasing, that means that the derivative of f needs to be negative, right? So f prime needs to be less than 0. So we'll take the derivative of kx over x squared plus 1. F prime should be x squared plus 1 times the derivative of kx, which is k, plus kx times the derivative of x squared plus 1, which is 2x, all over x squared plus 1 squared. Everybody good with that derivative?
Yeah.
Okay.
Don't you subtract kx times 2x?
Oh, yeah. Did I add them? Oops. Sorry. Minus. Yeah. My bad. All right. So I got a little bit of a distraction here. So then we're looking for when is this negative. So the denominator is never going to be negative, right? X squared plus 1 squared is always positive, no matter what value of x you put into that. So really, we're just looking at when is the numerator negative. So we'll factor out well, let's actually distribute it all together. So we have kx squared plus k minus 2kx squared. We want that to be 0. So we simplify that down to get negative kx squared plus k equals 0. And if we want to solve that, we'll say kx squared equals k. And then we'll divide by the k and get x squared equals 1. So that's true when x is positive or -1. Actually, we gotta go back. We can't cancel out that k. We want to know what values of k make this thing positive, right? So I forgot what we were actually doing with the problem. So we'll factor out the k. Sorry, k times 1 minus x squared. And so from -1 to 1, 1 minus x squared is always going to be a positive value. Everybody agree with that? Plug in something like 0, it comes out to be positive. Something like a half, it's going to be positive. -1/2, it's going to be positive. Everybody good there?
Sense.
So then to make this thing negative, we just need k to be less than 0, which would appear to be choice A. Everybody good there?
Very, thank you.
Yeah, sure. DM, these questions are all in the Google Drive. Different practice tests that I put up there. They're all called, let's see, they're called AP Calculus AB 2012, 13, 14, or 15. They're all just in the Google Drive. Okay. Let me know if you still can't find them. I can figure something out for you, but okay, next one we got here, it's in the assignments folder, is something similar to number 20 from 2012. Okay, let me look at that. Oh, the inverse one, okay. So let's see here. let's let f of x equal, I don't know, let's say, about 3x plus 2 to the 4th power. And that we know that the point 0, 16 satisfies this equation. And we want to find g prime of 16, given that f and g are inverses. Is that what you're looking for, Evan? Something like that?
Yeah, I wanted to look at like a new problem of something similar. So yeah, that's good.
Okay, so g prime of 16, since f contains the point 0, 16, g must contain the point 16, 0. And so that means that g prime of 16 is 1 over f prime of 0. So you find the derivative of this. F prime is 4 times 3x plus 2 to the 3rd times the derivative of 3x plus 2. So if we evaluate that at 0, that ought to be 2 cubed, which is 8, times our 4 is 32, plus our 3 is 96. So g prime of 16 ought to be 1 over 96. Does that make sense?
Yeah, the answer key I was looking at had like a way to do it that was different from anything I think you taught us. So I just wanted to see how you did it again.
Did they actually find the inverse of f?
Yeah, they just like all put it into one equation, and it was like, I just wanted to see it explained again.
All right, so you're good?
Yeah, thank you.
Sure. All right, let's see here. 2015, number 28. So give me a second to pull that up. 2015, 28. Sorry, I keep having to go back and forth between the different tests on my phone here. Oh, that's the ladder problem, yeah? There's a lot going on there. All right, so we got a ladder with a right angle here, obviously. It says it's 15 feet long. The ladder's length is not changing. So even though this is a related rate, since the length of the ladder is not changing, I'm going to put that 15 on. And then let's see here. It says that the ladder is sliding down the wall at a constant rate. So the rate at which it changes is dy dt. Sliding down at 2 feet per second is going to be a rate of change of -2. dy dt is -2. And then let's see here. It says we want to know what rate theta is changing. So we're looking for d theta dt. And then we're interested in that when x is 9. Okay? So we should be able to find what y is. Y ought to be 12, just using the Pythagorean theorem. And so if we want d theta dt, well, we just need to relate the y with, let's say, the hypotenuse. So we could say that the sine of theta is y over 15. And then we'll take the derivative of both sides with respect to t. So cosine theta d theta dt equals 1/15 dy dt. The cosine of theta is just adjacent over hypotenuse, so that's 9/15 based on the 9 that we found, or that they gave us there. So 9/15 of what we're looking for is equal to 1/15 times -2. You cancel out your 15ths, and you end up with d theta dt equals -2/9. Looks like that's choice A. Everybody good with that?
Yeah.
Anybody else? Any other questions? That's the last one that anybody's asked. Oh yeah, I've got my general test taking tips. Yeah, we'll do our general test taking tips now, I guess, and then we'll go into some of the free response questions that are up in like the My AP classroom stuff, which we'll go through in a second. So yes, the test starts at 8 a.m. Pretty sure the school has told you to get there before then now.
Yeah,
So theoretically, they've sent it all to you.
How early did they want us to get there? I didn't get any information about that. I'm sorry.
So I don't know.
1 hour early. It's in like the slides, but they said like an hour early, which is really early.
Yeah, that
Oh
is.
no.
Yeah.
Okay. Thank you.
Speaking of that, Cassie, 7 a.m. I won't be at school by then for you to drop your bag.
That's fine. Hopefully they'll let me keep my phone with me because they need it for a clear pass anyway. But like it says in the slides, no phone, so I have no idea. Hopefully they'll let me keep it, or at least.
They'll probably let you just like throw your backpacks like up against the wall. Is my guess. Did anybody take the physics test today? That's in here. They might know. No, nobody in here took the physics test today. Well, I'll try to figure that out from somebody that took the physics test today because I had a bunch of kids in DC take that. And I'll let you guys know what they said about bringing in a backpack with the phone in it or something. Should be fine, I think. Yeah. Sorry,
Do we get any breaks during the test?
House and I can't hear anything. Give me 1 second. Sorry, say that again. I just couldn't hear anything because of the plane going over.
Do we get any breaks during the test?
They will probably give you like 5 minutes, maybe 10,
Okay.
for multiple choice and the free response sections.
Okay.
Yeah, but other than that, there's no breaks. So, yeah.
And so then on the free response, do we just like circle our answer on the paper?
On the free response?
Yeah.
Yeah, just put a box around whatever your answer is and make sure you have all your justifications written out.
Okay, cool.
Yeah, so just real quick, I'll go. I think I did this all with you guys that are in quarter 3 before you guys left, but that's been 3 or 4 weeks now. So some of the things to remember in general about this AP test is, what is your question, guy? If the test ends early, can we go to 3rd period in person? If you're an in-person person, I would imagine you can. If you're not an in-person person, I don't think you can. Okay, so on your AP test, let's first talk about the multiple choice. In the multiple choice, some of the questions will probably take you like 30 seconds to a minute. Do those ones first. And some of them might take you 4 or 5 minutes. If you see a problem that you know is going to take you more than 2 minutes to do, skip it. Okay, come back to it later. Do all the quick and easy ones first. Every multiple choice question is worth the same number of points. So, doesn't really matter if you get through the first 17 questions because 8 of those took you forever and then you neglect the next 13, that's not good. So if you can get through 27 of the questions and guess on 3, that's better. So make sure that you do that, right? Skip the ones that are going to take you a while, come back to them later when you have time. Eliminating the options and then take a guess if you don't have time at the end. Okay. On the calculator sections, whether it's free response or multiple choice, make sure that you don't round anything until you get to the very end. Okay? So don't round until the last value, your answer. Then you can round that to 3 decimals or more if you wish, but at least 3 decimals. Okay? Don't put anything less than 3 decimals unless it specifically tells you to. So every once in a while, there'll be something where it's like, round to the nearest whole number. That's fine. Just pay attention to what it says about that. If it doesn't say to do that, then 3 decimals all the time, any calculator section. Let's see. In terms of the free response, there may be something in, I don't know, let's say part C of one of them that requires an answer from part A, right? Maybe you don't know how to do part A. That's fine. Make something up. Write 2x plus 5 equals 7 and solve it and get an answer for part A, and then use that horrible answer for part C you need it for, and then at least you'll get the points for part C, at least some of the points for part C. So don't let problems that are earlier in the problem, or the questions, the parts that are earlier in the problem, stop you from getting points later in the problem. Okay. So that makes sense, everyone?
Yeah.
Okay. Let's see here. What else do I normally tell everybody? The rounding thing. I've said these things like 25 times in the last week. I'm forgetting them all. Let's see here. I'm not trying anymore. Oh yeah, these things about the calculator, especially about the calculator stuff. So the calculator on the AP test should only be used to do basically 4 different things. One is evaluate the value of a derivative at a point. So if they ask you what is, f prime of 6 given some unpleasant function that you're given a calculator for, use your calculator to evaluate it. Don't try to take the derivative by hand and then plug in 6 on your calculator. Okay? Just type the function into your calculator, use the derivative function, find the derivative at 6. When you do that, make sure you write f prime of 6 equals. And if you don't do that, if you just put a number, they will not give you the points. So you have to write, f prime of 6 equals and then put the answer. No other work needed. Same with the definite integral, right? If they want to know the integral from 2 to 5 of, I don't know, e to the x sine x, then write the integral from 2 to 5 of e to the x sine x equals and put an answer. Have your calculator do the work. You don't need to integrate e to the x sine x. You just need your calculator to do it for you. That makes sense to everyone?
Yes.
Yeah. Just make sure that you write what you're having the calculator do. If you need to find the point of intersection of sine x and e to the x, write e to the x equals sine x, and then use your calculator to figure out where they intersect. Easy enough?
Yes.
Yes. Okay, good. What else? I mean, you can use it obviously for like arithmetic calculations and stuff in the calculator section, but usually you don't need to. Let's see here. What else? You can use it to graph functions to see what they look like. That's fine. But if you're using what the graph looks like, sketch the graph generally. Let's see here. If the test asks you for a maximum or a minimum, you should give a y value, right? Maximum or min means give the y value. If it says where does the max or min occur, that means you need to give an x value. So always be careful about what it's actually asking you. See what the question is actually asking you and then answer that question. Okay? Make sure you write out your justifications nicely. Make sure they make sense and make sure your justifications are actually justifying what you've said. Sometimes people write random nonsense. They're not going to give you points for that. Let's see here. Yeah, that's about it for like basic tips for the specific calculus test. Anybody else have any other questions? And then we're going to start going through some of these free response.
I have kind of like a comment / question.
Okay.
So I was like, notice a lot of the calculator section of the multiple choice, you don't need a calculator. Like,
Correct.
is just super common to have a lot of it just not even need a calculator, even though it's in the calculator section?
Yep, like half of it you probably won't need it for.
Okay. Why do they do that?
I don't know. Good question. They just do. Because there's not that many things to test in the in the calculator multiple choice section. I mean, like, what are they going to do? Ask you to evaluate integrals and stuff? It's all got to be fairly conceptual if they give you a calculator. Because if they give you a calculator, you can just plug it in. So they don't want to test, can you evaluate this thing at 7, really. They want to know, do you understand the concept of why you might take the derivative of something and evaluate at 7? Like they might say, here's a velocity function, what's the acceleration at 7? Sure, use your calculator and figure that out. Right? But it's a conceptual thing, not a can you take the derivative thing. Does that make sense?
Yeah.
Yeah, I'm pretty sure they let you bring extra batteries. You can also bring up to 2 calculators. So if you have a second one, you can just bring a second one. For those of you like me that have like 12 graphing calculators. None of which work because battery acid leaked in most of them when I didn't use them for like 6 months. Fun times.
Oh no.
Any other general questions before we start talking about some of these other free response? All right. So in terms then of free response, what I'm going to do is I'm going to put up, if you guys have specific topics from free response you want me to talk about, or problems that we want to do, then I'll put up. Are there any? Yeah, there is a list of calculators online. Yeah, Sean, there is a list of calculators that are not allowed. So pretty sure I checked to everybody and told you guys to check at the beginning of the year. What calculator do you have? I'm pretty sure that one's fine, but just go on Google and search for approved calculator list, calculus AB. They'll have the list. It's on the college website. DM, there are 4 full practice tests in the Google Drive that you guys were supposed to be working on the last few weeks, and we did in the last couple of weeks of last quarter. They're all up there. At least there's actually 5 of them. 2008, 12, 13, 14, and 15. It's got all the stuff in there. All right. Let's see. So one with related rates with 3D figures like drinking troughs or something being filled up with water. Okay, sure. Let's do, I don't have a specific free response. I don't think that uses that. I don't remember for sure. Let me just quickly look through here. I don't think I do. Oh, this might. Yeah, this is not what you want. No, that's not going to do it either. Yeah, I don't think I have a specific one for that, but I can make one up real quick. So let's say we've got, I don't know, let's just go with a cone with its point down with the radius equal to 3 times the height. And it's being filled at a rate of 5 cubic feet per second. And then let's say when H equals 2, let's find dHdt. Find the rate at which the height is changing, the depth of the water. Is that what you're looking for? Who asked that? Something like that topic? Yeah. Cool. So, all right. So we're going to look at this one here. First off, we need to know that the volume of a cone, which they would most likely give you, is 1/3 pi r squared h. we're looking to do everything in terms of h. We're looking for dh dt given a specific height. So we need to turn all the r's into terms of h. So if r is 3h, then r squared would be 9h squared. So we'll plug that in. We have a 9 over 3, that's going to be 3 pi h cubed. Everybody good with that?
Yeah.
Then we'll take our derivative. dv dt equals 9 pi h squared dh dt. And we'll plug in our dv dt value of 5 equals 9 pi times our height squared dh dt. And then we will divide. So what is that? 36 there, 36 pi, so 5 over 36 pi. That make sense?
Yeah.
Units would be feet per second. Cool. Everybody's good with that? Somebody else just asked me. So let's see. Cassie, one using linearization. Okay, so linearization, usually they'll ask you to do something like approximate f of 2.1 if f of x equals some unpleasant function. That doesn't really matter. We'll just, I don't know, we'll say x squared e to the x or something like that. So we want to approximate 2.1. We know that f of 2 is just 4e squared. So we would just say that, approximating f of 2.1, that should be, or we'll say approximating 2.1. So we'd say that our change in x is going to be 0.1. Our x value will be 2. We'll get some value close to 2.1. It's easier to evaluate, 4e squared. And so then we will say that the change in the y value should be the derivative of this, which would be x squared e to the x plus 2x e to the x dx. And so our change in y, we might write this as dy. A change in y ought to be this, where x is 2 and dx is 0.1. So our change in y would be 4e squared plus 4e squared times 0.1, and which would be 0.8e squared. And so we would say that y changes by about 0.8e squared. So it goes from 4e squared to about 4.8e squared. Does that make sense?
Yes, it does. Thank you. So for linearization, the Q would be something like approximate. That's how, or like approximate and then something really close to the number. And so you know that it wouldn't be doing something like, I don't know. You wouldn't be doing.
That's right. Yep, that's exactly right. Or they might say like, often it comes up like this: approximate the change in the surface area of a sphere if r changes from 2 to 2.1. We'll just use the same values there. So if r changes from 2 to 2.1, really bad. Surface area of a sphere, change in surface area ought to be 8 pi r dr. R is 2, dr is 0.1. So just plug it in, 16 pi times 0.1, or 1.6 pi. That's another way you might see it.
Thank you.
Yep. Other general questions from anybody? All right. In that case, let's just start here at the beginning with some of these free responses. And if you guys want to move forward to any other types of free response at any point, just let me know which specific kinds you want, and we'll talk about it. So I'll give you guys a second to read through this one, and then we'll start working through it. So if I take 2 minutes and just sort of think about what you might do for each thing, and then we'll go through them. And this is one that's not posted up, so you just have to look at it here on the screen. So how would we do part A? How would we find the limit as x approaches 0 of f minus g? Or S to G.
Oh, sorry.
What's that?
I'm pretty sure limit rules say you can just do like limit of f of x minus limit of g of x.
Yep. So we'll do the limit as x approaches 0 of f minus the limit as x approaches 0 of g. As x approaches 0 for f, our graph, that looks like that's 2. And for g, looks like it is also 2. So it looks like that should be 0. Yeah. Everybody good with that?
Yeah.
Wonderful. All right, for the second part, we've got a equals 1, 2, 4, and 6. Find the limit as x approaches a, or explain why it doesn't exist. So I'm not going to write everything out here, but if we're talking about at a equals 1, right, we would say that at a equals 1, that limit does not exist, because from the left and from the right, it approaches different values. Everybody good with that?
Do we actually have to write out what the right hand and left hand limits are, or do we just say they just approach different values?
Yeah, you would want to write them out. Yes. That's what I'm saying. Use the correct limit notation, right? So write it all out. Just to save time for us right now, I'm not going to, but we'd say it doesn't exist because the limit from the left is 1 and the limit from the right is 0. For a equals 2, that one should be just 1. Doesn't matter that the point isn't defined there. The limit is still 1. For a equals 4, it looks like it's -1. Okay. And for 6, looks like it's going up towards infinity. So you could say infinity, or you could say that it doesn't exist. It's up to you. They would accept either one. Good or no?
Wait. At a equals 1, would it be? Are the limits approaching the same thing? Am I just looking at something weird?
I'm sorry, say that again.
As for a equals 1, shouldn't it be that there's no limit there? Because
Yeah, isn't that what I said?
oh, I thought you said that it wasn't defined, but there was still a limit. Never mind.
And at
Sorry.
2, there's still a limit, but it's not defined. The function is
Okay.
not defined, but there's still a limit. And for 1, the function is defined, but the limit is not. Does that make
Got
sense?
it. Yeah.
1 second. Sorry about that, everybody. Okay, I don't even remember what I was saying, but I do have a question in the chat. Sadek, you asked which one's safer, infinity or doesn't exist. They are both safe. Either one you put will be accepted, guaranteed, as long as it is infinity. So it doesn't really matter. I mean, if you say it doesn't exist, that's fine. Doesn't really matter. Well, I was in the middle of saying something. I feel like before I had to.
You were answering for me about like how the limits worked, but I think you had mostly finished like what you were saying.
Okay, so you feel okay about part B now?
Yeah.
All right, cool. All right. Part C says, is f continuous at -3? Using correct notation, justify your answer. So they like to occasionally ask if something is continuous at a point. So wonder if it's continuous at -3. That means that f of -3 has to exist. Can you guys hear me? It says my internet connection is unstable.
No, you're fine now.
Okay. It says that f of -3 is existing. The limit as x approaches -3 of f exists. And that these two things are equal. So what is the limit as x approaches -3? It should be -1. And what is f of -3? It is 2. Since those two things are not equal, we would say no, not continuous. And that's the justification that they'd want to see. The f of -3 exists. The limit as x approaches -3 of f exists, but those aren't the same, therefore not continuous at -3.
You have to mention the values, or can you just write out that the limit doesn't equal to the actual value?
They'd like to see the values.
Okay.
Yep. All right. Then for part D, we're going to write a difference quotient that best approximates the instantaneous rate of change of g at 0. So a difference quotient is just a slope. So all we'll do is use the smallest interval surrounding 0, 2.001 minus 1.999 over 0.001 minus negative 0.001. That'd be it. Approximating the derivative or the instantaneous rate of change of g using an average rate of change. And remember that an average rate of change is just a slope. And on a small interval, that's a approximation of the instantaneous rate of change. Everybody good there?
Yep.
Cool. All right. Oh. Sure, we can do a differential equation one. Let's see here. I had a nice little slope field one in here somewhere. Let's see if I can find that one. I swear I did. There it is. Does that one look good, Alex?
Yeah.
Perfect. All right. Why don't you guys just take 2 minutes here, look through it, and see if you could conceptualize what you would do. Then we'll do all the work together. So I'll give you guys 2 minutes to think about it. You guys have a general idea what you'd be doing for each part? Ready to go through it?
Yep.
Okay. So first thing is sketching the slope field. Like I said, they don't have to be perfect. They just have to be pretty accurate. So first off, we note that anytime that x is 0 or y is 0, slope should be 0. So there's a bunch of places where y is 0, a couple of places where x is 0. Those are all 0. Easy enough.
Yeah.
Okay. That would be worth 1 point. So the zero slopes are always worth a point, or almost always worth a point. And the other ones are also worth a point. So just plug in the points. 1, 1 gives you 1. 1 and then -1 for y gives you -1. -1 for x and -1 for y should give you +1. And then -1 for x and +1 for y ought to give us -1. So that would have been worth 2 points. Everybody good with that? Hopefully.
Yep.
All right. So part B, we'd be looking for the second derivative. So our second derivative, we'll take the derivative of xy cubed using the product rule and implicit differentiation. So x times the derivative of y cubed, which will be 3y squared dy dx, and then plus y cubed times the derivative of x, which is just 1. And then we have to replace the dy dx with xy cubed. So we have 3xy squared times xy cubed plus y cubed, which would become 3x squared y to the 5th plus y cubed. Then they're asking us about concavity for quadrant 4. So they'd want you to note that in quadrant 4, x is positive and y is negative. And so if you have a y value that's negative and an x value that's positive, 3x squared is positive, but y to the 5th is negative. So you've got a negative plus another negative, which is definitely going to be less than 0. So that's telling us that since the second derivative is always negative based on those x and y values, this thing is always concave down in the fourth quadrant. And this would be enough. You would say that in the fourth quadrant, you show your second derivative. You'd say x is greater than 0, y is less than 0. So the second derivative is less than 0. And that'd be enough justification. Good or no?
I had a question about the last question because I blue screened. When it asks you for the difference quotient in part D, do you write like the limit definition of a derivative, or you just do like basic slope?
No, the difference quotient is just the slope formula. The limit of the difference quotient is the definition of the derivative.
Oh, okay.
We're
So just by
using the
itself,
difference
it's
quotient to
basic.
approximate the average rate of change. So you're using a slope to approximate the instantaneous rate of change. So you're just using the difference quotient to approximate the derivative. Does that make sense?
Yeah. Thanks.
Yep. All right, everybody good with A and B?
Yep.
Cool. All right. Part C asks us to solve this differential equation with the point 2, -1. So this is the major number of points for this problem. This is a separable differential equation, so we'll separate the variables. dy over y cubed equals x dx. Integrate both sides. Remember that dy over y cubed is just y to the -3. So if you integrate y to the -3, you got to get -1 over 2y squared is x squared over 2 plus the constant. Everybody good with that?
Yeah.
Okay. Then you'll find your constant by plugging in 2 for x. So 2 squared is 4 over 2 is 2. And then -1 here is just going to give me -1/2. Our constant is -5/2. And so we end up with -1 over 2y squared equals x squared minus 5 all over 2. X squared over 2 minus 5/2. Everybody good there?
Yeah.
Okay, take your reciprocal, -2y squared equals 2 over x squared minus 5. Divide by -2. Dividing by the 2 will make it a 1 in the numerator. And And then dividing by the -1 will turn this into 5 minus x squared. And then we square root. And when we square root, we have to note that it's either positive or negative. So we need to choose the correct one based on our initial condition. So if we plug in 2 for x, we need to get -1 for y. Well, square root's always positive, so we need to choose the negative square root so that we get -1. That makes sense to everyone?
Yeah.
Cool. And they do not ask for the interval of validity most of the time. If they do, I mean, I haven't seen them do it since like 2002. But if they did, you just figure out when this thing in here is undefined and you pick the one interval that includes the initial condition where it's continuous. One sec. Okay, sorry about that. Everybody good with that one or no?
Yeah.
All right, wonderful. Anybody have any other specific types of free response you want to talk about? You're welcome, Cassie. Good luck. And
Thank
good luck.
you. Have a nice day.
Yep. Anybody have a specific free response type they want to talk about? Otherwise, I'll just pick another one. Okay, I'll just pick one. Let's see. Allie, you want to do another differential equation one or no?
Sure.
Sure. All right, so let's take a look at this one. This one where you have to sketch the slope field. So I'll give you guys 2 minutes to look at it and decide what you do, and then we'll talk about it. 2 minutes to look at this one. All right, you all have a general idea what you'd be doing?
Yeah.
All right, so first off, sketching through 0, 1 is just that horizontal line. Make sure that yours looks better than mine, that you don't put arrows at the end, and that you extend to the end of the region. 0 to 5 halves should just look something like this. It would appear. It's kind of, mine's not super great looking there, but generally something like that. Everybody good with that? And that would be worth 2 points most likely. All right, part B, they like to ask you to do this in the free response on differential equations. Write the equation of the tangent line to the curve at 0, 5 halves. So first off, find the slope at 0, 5 halves. So plug that into dy dx. So if x is 0, this becomes cosine of pi. And if x is 0, that's just a 1. And 5 halves minus 1 ought to be 3 halves. So 3 halves cosine pi. Cosine pi is -1. So our slope would be -3 halves. Everybody good with that? Yeah, Krista, I'll do a rate one after this one. So we then just do y equals -3 halves x plus 5/2. I just use slope-intercept form because they gave us a line-intercept. Sometimes they'll ask if that's an under or an overestimate. You need to find the second derivative to determine that. So remembering that if the second derivative tells you that it's concave up, the tangent line is an underestimate because it's below it. If it's concave down, tangent line is an overestimate. Everybody good there? Okay, so then we'll solve this differential equation. That's it's not too bad. All right, let's rewrite this on the next page. dy over y minus 1, right, equals x plus 1 times the cosine of x squared plus 2x plus pi dx. So I integrate both sides. This side is just natural log absolute value y minus 1. The other side, well, that's an x. We'll do a u substitution. So we'll note that if we let u equal x squared plus 2x plus pi, then du ought to be 2x plus 2. And we'll then have to put a 2 on the inside and a 1/2 on the outside. If I put a 2 on the inside and I distribute it through the x plus 1, that'll become 2x plus 2. And then the 1/2 on the outside. So we end up with 1/2 the integral of cosine u du. Natural log absolute value y minus 1. 1/2 integral of cosine u is sine u. So sine of x squared plus 2x plus pi plus a constant. And what was our initial condition? 0, 5/2. So if x is 0, y is 5/2. We end up with the natural log of 3/2 equals 0 plus our constant. So our constant is natural log of 3/2. We've got natural log absolute value y minus 1 is 1/2 sine x squared plus 2x plus pi plus ln of 3/2. And then we'll raise these both as powers of e. Get the absolute value of y minus 1. The e, the ln 3/2 comes out front as a constant. We end up with e 3/2 e to be 1/2 sine x squared plus 2x plus pi. You clear off your absolute value by deciding if it's positive or negative. It's clearly going to be positive because we get 5/2. Then we'll just add the 1 over. So just gonna run out of room here. We're just gonna say y equals 1 plus this. And when x is 0, we'd see that this becomes e to the 0, which is 1. We get 1 plus 3/2, which is 5. So it should work out. Everybody good with that or no?
Makes sense.
Wonderful. All right, Krista, you said you wanted to rate one, right? That looks like a good one. Calculator one. So I'll give you guys a second to read through it and then we'll work our way through it. Does that one look like what you're looking for, Krista?
Yeah, thank you.
Yep. All right, we all good? Everybody have a good idea? You need another second to look at it. Anybody? You guys ready or no?
I think we're good.
All right, so
Oh my God.
first thing is we are writing an equation for the linear approximation of W at T equals 3. So W is the volume of the water in the volume of the water in the tub. And so if we are looking for W of 3, we know that there's 2.5, sorry. Yeah, okay, so we're writing the approximation of W at T equals 3. Sorry, I should have read it while we were going through this. So the volume of the water in the tub is W, which should be the integral of, let's see here, should just be the integral of f from 0 to some t value, and so we're talking about at 3. So our linear approximation should end up being W of 3 plus W prime of 3. This is your linearization formula times your t minus 3 value. And W of 3, I believe they gave us, right? That's 2.5. W prime of 3, which should just be, since W is this, W prime is just F. So W prime of 3 ought to just be F of 3, which I don't know the value of, but you can find it. And then 3.5 minus 3, since we're approximating it at 3.5. So whatever this comes out to be would be your answer for part A. Does that make sense to everyone? And you'd have a calculator, so you just evaluate that function, the inverse tangent of pi over 2 minus 3/10. Take half of it and add 2.5. Any questions on that or no?
Do we have to write out f of t, or can we just say f of 3 and then just do the calculator?
You just use your calculator and figure out what it is. And then, yeah. What I wrote is enough as long as you evaluate what f of 3 is and then figure out the final answer. Is everybody good with that? Krista, you good with that one since you're asking about the rate one?
Yeah, thank you.
Then B is fine. W prime, right? W double prime of 8. So W double, that's hard to say. W double prime at 8 should just be, since we're looking at it at 8, now we're concerned with how much water has leaked out of the tank as well. So W double prime ought to be F prime minus L prime, and we'll evaluate both of those at 8. If you're given the function for F and the function for L at 8, you will just use your calculator to approximate both of those and get an answer. So that would be enough work to show for part B, and then you'd have to interpret the meaning of it. And so if you're taking the derivative of some rate functions, it's just the rate at which the rate of change of the volume of water is changing. Does that make sense or no? So it's the rate of change of the rate of change of the water. Everybody good with that or no?
So we don't have to divide by the time.
Nope.
Okay.
You're looking for the second derivative of W.
Okay.
So nope, we don't need to do that. All right, part C says, we want to know if there's a time when the rate of change of the volume is changing from positive to negative. So the rate of change of the volume from 5 to 10 is just F minus L. So we just want to look for F minus L. When does that equal 0? And we'll check and see when it equals 0, and then we'll make sure that it actually changes sign. So we would just graph F minus L and look for any sign changes anytime it crosses through the x-axis between 5 and 10. Any questions on that? Does that make sense?
Yeah.
Cool. And then part D tells us that the tub is in the shape of a rectangular box, 1/2 foot by 4 feet by 3 feet. We want to know the rate of change of the depth of the water in the tub at t equals 6. So the depth of the water is not something that we really need to concern ourselves with, because we're just looking at the rate of change of the depth of the water. So the volume of this amount of water should always equal 1/2 of the width times 4 times whatever the height is at any given time. So our rate of change of the depth of the water, dv dt, ought to just be 2, since that's already 2h, that ought to just be 2 dh dt. Everybody good with that? And then, let's see, what does it say at time t equals 6? So the change in the height of the water at t equals 6 ought to be f of 6 minus L of 6. Sorry, not the height of, sorry, that's not dH dt, that's dV dt. Right, our change in the volume is f of 6 minus L of 6. So you'll plug that in, divide it by 2 to get your dH dt. Okay. F minus L is the rate of change of the volume of the water. Everybody good with that? And you just divide that, whatever f of 6 minus L of 6 is, divide it by 2. Good or no?
Yeah, thank you.
Sure. Anybody else, any specific types you want to talk about?
Can we do one where like we're given a graph and they ask us like different integrals and stuff on the graph?
Let's see here. I think this is the best one of those that I've got, where they just give you specific areas. Sometimes they like to give you the areas of random pieces.
Yeah,
This-
sure. That's
Something
good.
generally like this, is that what you mean?
Yeah.
Cool. Well, 1 second here. Let me. Okay, because I couldn't read the top of the problem because of the Zoom bar there. All right, I'll give you guys like a minute or two to read through it, and then we'll go through it. All right, everybody good with reading through it?
Yep.
All right, so first off, we want the value of the integral from 0 to 7 of f prime. That's just the area between 0 and 7 and the curve. And the area from 0 to 7 between the curve and the x-axis. So that ought to be 2, which is above, minus 7, because that's below, plus 3, plus 1. So looks like that is negative 1. Everybody good with that? Just noting that anything below the x-axis is going to come out to be negative. Yeah? All right. Part B. So they tell us that f of 4 is 10. We want to write an expression for f that involves an integral. So we're going to use that expression to find the absolute minimum of f and the absolute maximum of f on the interval from 0 to 7. So if f of 4 equals 10, that means that we want to write this. Oops. What's wrong with my laptop over here? Something's wrong with my laptop. All right, sorry. That we want this to be an integral from 4 to x of f prime of t dt plus 10. That's the function that represents f of x. Because that way, if I plug in 4, I get 10, and it still gives me all of the area underneath the curve as the value for f, which is the integral of f prime. Does that make sense to everybody how I got that?
Yep.
Okay. So then we want to find the absolute max and the absolute min. So we look for anywhere where the function crosses through the x-axis, or f prime crosses through the x-axis, because that's where it changes signs. So looks like it crosses through the x-axis at 1, but that's the only place. So we have a critical value at x equals 1. Since we have a closed interval, we'll also check the endpoints, x equals 0 and 7. So we're going to find the value of f of 1, f of 0, and f of 7. So f of 7 is the integral from 4 to 7. So f of 7 ought to just be 3 plus 1, ought to just be 4. Everybody good with that? F of 1 ought to be the integral from 4 to 1 of f prime, which is just the opposite of the integral from 1 to 4 of f prime, which is the opposite of negative 7, which is 7. So f of 1 is 7, f of 7 is 4. F of 0 ought to be the integral from 4 to 0 of f prime, or the opposite of the integral from 0 to 4 of f prime. Everybody good with that? And the opposite of the integral from 0 to 4 ought to be the opposite of positive 2 minus 7, because the 7 is below the x-axis. Everybody good there? So 2 minus 7 is negative 5. The opposite of negative 5 is 5. So on this interval, we know that the other place where it crosses through is at 4. I forgot to mention that one. X equals 4 is also a possibility. And the integral from 4 to 4 of f prime is 0. So our absolute min is 0. And our absolute max is at 1. Does that make sense to everyone?
Wouldn't the absolute minimum be?
From all of those, didn't I?
Oh, you have to add 10. Yeah, sorry.
Yeah, sorry, I totally forgot I had a plus 10 there. That's my fault. So sorry. Every single one of those add 10 to it. So this one is 10. This one is 15. This one is 14. And this one is 17. So plus 10 to all. That's my fault. I totally forgot about the plus 10, but the max and the min still occur in the same place. It's just the max is 17 and the min is 10.
Okay, thank you.
Sorry about that. I don't know why I left off that plus 10 after we wrote it, but any other questions on part B there?
Why isn't 6 considered a critical value?
Because it doesn't cross through the x. Well, it's a critical value, but there's no sign change in the derivative, so it can't be a max or a min because there's no sign change.
Okay, I see. Thank you.
For this one, would we get partial credit if we did something like that and forgot 10, but we still got like the minimums and maximums, right?
Yeah, you probably get all the points for but one, because there's probably 1 point associated with the initial condition, and the rest are finding the x values where they occur.
Oh, okay, thank you.
Yep. All right, part C, find the integral of g. Well, that's easy. 5x minus x cubed over, I wrote that like that, x cubed over 3 plus a constant. Yeah, everybody good with that? Okay, that should be easy. And then we want the integral from 1 to 2 of x and then f prime of g. So if we want to figure out that integral, my suggestion, I gotta move the Zoom screen over so I can make a new page now. All right, so we have an integral of x, what is it, x, and then f prime of g.
Yeah.
From 1 to 2. So I would, since there's a g composed inside the f prime, I would let u equal g of x, which is 5 minus x squared. And that would tell me that du is negative 2x dx. So I'd put in a negative 2, and I'd put in a negative 1/2. And so we do negative 1/2 of the integral, and the negative 2x dx would become du. And we just have f prime of u du. And then if x is 1, then u is 4, 5 minus 1 squared. And if x is 2, then the upper limit is 1. So we're looking at negative 1/2 of the integral from 4 to 1 of f prime, which would just give us 1/2 the integral from 1 to 4 of f prime. No reason to substitute back in the u. We can integrate f prime just by looking at the graph. The integral from 1 to 4 of f prime is negative 7. So we'd end up with 1/2 negative 7. Negative 7. Does that one make sense to everybody?
Yep.
Any questions on that, anyone? Everything's good. Any other particular types we want to do? Probably got time for one more.
Can you do a question that involves like a table in our answers?
Oh, a table. In your answers?
Yeah, because I know in the past for some things we've had to write a table for like an explanation kind of thing.
Oh, I see what you're saying. Like, yeah. I know what you mean. Let me see if I can find one in here. Don't happen to know offhand if we have one in here. Probably be in like a
It's
rate.
okay if you don't, it's not a big deal.
Can we do optimization?
Maybe. If I can find one in here also. I can always make one up, but I don't think there's one where you need a chart in here. The only one I would have said that you would need a chart would have been that rate. No, not the rate one. Actually, it was the one we just did, right? Where we would have made a chart with all of these values. We would have said like at x equals 0, it's 10, at x equals 1, 17, at x equals 4, no, I said it's 4, at x equals 0, it was 15, and x equals 7, it was 14. So you just make a chart of those to prove the absolute max or absolute min. I don't think I have another one like that though. It usually occurs in like the rate problems where they'll ask you like, what is the maximum amount of water in the tank? And so you'll find the critical values and then you'll integrate at the endpoints to show how much is at the beginning, how much is at the end, and how much is at the critical value, and just make a chart of those. Other than that, you don't really need a chart for your explanation for anything.
Okay, thank you.
Yeah, hopefully that makes sense. And then somebody's saying optimization here. Correct, Josh. Yes. I don't know if I have, there's not usually an optimization per se in the free response. I'm not sure if I got one in here. People are dropping like flies here. Be like 30 seconds, somebody leaves. Yeah, I don't think I have an optimization one in these free response. I don't know. Maybe it'd be helpful if I just talk a little bit about optimization. So when you're doing optimization problems, just make sure that you remember the ways that you're going to often set them up are using the Pythagorean theorem or similar triangles or relating like a volume to a surface area potentially. And then all you're doing is writing a function to represent the thing that you want the max or the min of. And then you take the derivative of that function, set it equal to 0, see when it's undefined, and then make a sign chart to prove that it's a max or a min. I don't have like a specific one here in the free response offhand. They usually show up as like fairly simple ones in the multiple choice. I don't know, does that help at all? Or I can try and make one up if you want, or find one.
That was good. Thank you.
What?
That was good. Thank you.
That's good. Okay.
I have a question about the test.
Yeah.
So do you know, are there any sections where like if you finish early, you can go back to another section, or is it like completely shut off when you like finish a section?
Well, it used to be, let me check on this. It used to be that if you finished the non-calculator free response, you could go back to the calculator free response just without a calculator. But let me check on that. Because I don't believe the school has been allowing that to happen. So it may have changed, and I don't remember seeing something that had changed, but give me 1 second. I don't think they let you do that anymore. So no, I'm gonna go with a no. It used to be that.
Thank you.
What's that?
I know, I just said thanks.
Oh, yeah. Yeah, I'm pretty sure you can't do that anymore. And they haven't been letting people do that at our school for a while, so I assume. Wait. Yeah, no, maybe you are. I can't find it on the College Board website itself, though. Um, it doesn't really say on the College Board website. You may move along with them. Yeah, I don't think they're going to let you do that. It used to be that you could, but I don't think you're going to. So. All right. Yeah, so I'm going to say no. Any other questions? I think we'll probably just be done. We got like 4 minutes to go.
How do you find arcsecant and arc cosecant on a graphing calculator? Because we don't have those functions like explicitly.
You're not going to need to, other than you might in the non-calculator section, just by knowing when the secant of an angle is equal to some value. But you won't have to do it on your calculator, I don't believe. But if you did, just take the reciprocal. So like if it's, if you're looking for arcsecant, take the reciprocal of what the thing you're trying to find the arcsecant of and do the inverse cosine of it.
And that works for inverse cosecant too, right?
Yep, if you take the reciprocal of what you're looking for and do inverse sine of it.
All right, good to know. Thank you.
Yep, chances of you having to do that are very slim, but just in case. Yep. Anybody else? Any other last second questions? All right, make sure you have your sharpened pencils and a pen if you want one for the free response, although you can do it in pencil if you wish. You guys will all do great. If you have any other questions tonight, you're welcome to send me a remind. I will probably answer for the next couple of hours, but then I'll be going to bed. So if you have anything else, feel free to ask, or you can ask in the morning, but I suggest you just sort of let it all sink in, go to sleep, get up and defeat the test. Cool. All right. That should be it.